Hello, my name is Jeanette Dimelo. I'm an advanced mathematics teacher at St. Peter Claver High School in the Dodoma region. Welcome to this class. Today we will be discussing differentiation, but to be specific, differentiation by using the chain rule. Now, what is the chain rule? The chain rule is actually one of the methods that simplifies differentiation of complex functions. What do I mean by saying complex functions? Functions that have functions within them. So I will show this example and then from there give you what the chain rule actually is. Let's say you've been given a function y equals x squared plus 2x plus 2 power 5. From this function, have you noted the following? We have power 5 outside, and we have x squared plus 2x plus 2. That's what I mean by saying complex functions. We have functions outside and functions inside. So if you were to use normal methods of differentiation, this would be very difficult. But what we're going to do is, by the chain rule, we shall start with the outside function. So step number 1 in such cases is differentiate the function outside. So we have this part of the equation, we have y. When you differentiate y, what do you get? You get dy dx. So dy dx equals to differentiating the function outside. That means looking at this function here, I'm recircling it again for you to see. When you differentiate the function outside using the power rule, if you remember from last class, this 5 comes down, so you'll have 5, and then the function inside the way it is, x squared plus 2x plus 2, and then 5 reduces by 1 to become 4. But have we finished? No, we have to go to step number 2. And step number 2 is differentiating the function inside. So differentiating this function inside, what do we have? When you differentiate x squared, you will have 2x. Why? 2 comes down, 2 reduces by 1 by the power rule. When you differentiate 2x, what do you have? You have 2. Why? When you differentiate x, it reduces by 1, you'll end up with 2. When you differentiate 2, what do you have? A 0, because 2 is a constant. So that is the second part. Now, from here, can we proceed? Yes. Why? Because we have 5. And we have this function here. So to simplify this further, we multiply 5 and this function here to get something more simplified. You'll have dy dx equals 5 times 2x will give you 10x. 5 times 2 will give you 10. And then the remaining function, which is x squared plus 2x plus 2 power 4. So that's simply an example that I've used to explain to you the chain rule. Now what is the chain rule? Simply differentiate the function outside, differentiate the function inside, and you're done. So I'll give you a second to go through this, and then I'll rewrite the chain rule and see another example. So this is the chain rule. dy dx equals dy du times du dx. In a second or two, I will explain to you what does this actually mean, using another example. So let's see example 2. And I will explain to you what is dy, what is du, what is du, and what is dx. Suppose we have a function y equals to 2x plus 4 power 5. How many functions do you see? We actually see 2 functions. Again, the outer function and the inner function. So what you can do by using the chain rule is to let either the outer function or the inner function be u. Letting the inside function 2x plus 4 equal to u. That would be step number 1. Step number 2 would be to look for du dx. But before looking for dy dx, we need to find what is dy du and what is du dx. So if we differentiate this on both sides with respect to x, you will have du dx equals to, when you differentiate 2x, what do you get? You get 2. When you differentiate 4, you get 0. Why? Because 4 is a constant. So we already have du dx, and we can call this equation number 1. So we already found the first equation, which is 2 equals to du dx. But remember, from the chain rule, dy dx equals to dy du times du dx. What can you observe from that chain rule? We have the first part of the chain rule, which is actually du dx. Now how do we find dy du? When you recall, from that equation we had let u equals to 2x plus 4. And our original equation was y equals to 2x plus 4 power 5. Now let's label this as equation A and this one as equation B. What we're going to do is take equation A into equation B. That means substitute. Wherever you have 2x plus 4, you're going to substitute u. So this equation now becomes y equals to, wherever there's 2x plus 4, I'll write u and then power 5. So this gives me a different equation. Now I need to use this equation to find the remaining part of the chain rule, which is dy du. So differentiate both sides, but in this case, differentiate y with respect to u and not with respect to x. So this becomes dy du equals to, same procedures by power rule, the 5 up here comes down. What do you have? You have 5 u, then 5 reduces by 1, you end up with 4. So this is our actually our third equation with 5u power 4. And let's call this equation x. Now, what we're going to do is we're going to use equation x and equation 1 and substitute it back into this chain rule. dy dx equals to, wherever I have dy du, I'm now going to substitute which equation? I'm going to substitute equation x. So instead of writing dy du, I will write 5u power 4. That's the first part. And then the second part with du dx, I'm going to substitute equation number 1, which is 2 equals to du dx. So multiply this by 2. When you multiply this by 2, 2 times 5 gives us 10. So dy dx equals to 10u power 4. But the funny question is, from my equation, did I have u in the beginning? No. So I need to go back to my equation and rewrite u in terms of x. So if you remember from equation A, u equals to 2x plus 4. So in this equation dy dx, which is now my final answer, I'm just simply going to write dy dx equals to 10. Wherever I have u, I'll use the substitution I made earlier, which is 2x plus 4, power 4, and that is my answer. So it's not difficult. In simple cases, what we're saying is we use two functions, the outside function and the inside function. So we differentiate the outside function first and then differentiate the inside function. And that simplifies to what we call the chain rule, of which is dy dx equals to dy du times du dx. So we've already seen how to differentiate using the chain rule. Now I'm going to leave you a question and see if you can manage this on your own. Try doing that question and please give your comments in the link below. Next video we'll be discussing differentiation by the product rule. Thank you so much.